You are looking at a live image of the Falcon 9 on our 39A launch pad at Kennedy Space Center as we step into the final minutes before our scheduled liftoff at 5:07 p.m. Eastern Time. Good afternoon and welcome to the live webcast of today's Falcon 9 mission launching Dragon to the International Space Station. My name is Lauren Lyons and I am a Dragon 2 certification engineer in our Flight Reliability Department. Now today's mission is particularly exciting because it is the first reflight of our Dragon spacecraft. The Dragon flying today originally flew on the Commercial Resupply Services mission number 4, or CRS-4 for short, and it's back again for today's CRS-11 mission to the International Space Station. Now on board Dragon today we have about 6,000 pounds of cargo. That's food, crew provisions, exercise equipment, and a number of research experiments, some of which we'll talk about later. We're also going to attempt to land our first stage of Falcon 9 back at Landing Zone 1, located approximately 9 miles from pad 39A. We've got a super exciting day today, so let's get started.
Good afternoon, my name is Tom Perderio. I'm a firmware engineer in the avionics department here at SpaceX. Now on your screen you can currently see the Falcon 9 rocket as it prepares to launch from historic pad 39A at Kennedy Space Center on the space coast of Florida. Now, in addition to this being our first reflight of a Dragon capsule, today's mission also marks the 100th launch from this historic launch pad. The first launch was actually an Apollo 4 mission back in November 9th of 1967, and now today, nearly 50 years later, SpaceX is once again getting ready to launch a fully commercial rocket and spacecraft from this historic pad. Now, the Falcon 9 you can see standing exactly where the Saturn V rocket once stood, and later on in this pad's history, also where the Space Shuttle once stood. In fact, some of the structures you can see behind the rocket are actually from the Space Shuttle era. This large squarish structure right behind the rocket is called the fixed service structure, and this one over here is called the rotating service structure, like I said, both part of the shuttle missions. Now, the Falcon 9 rocket has 3 main parts. The bottom 80% or so is the first stage of the rocket. On top of that is the second stage. And then at the very top is the Dragon spacecraft, which is what we're launching today. Now, normally when we launch satellites, we have a big fairing on top. That's to protect those satellites from aerodynamic forces of launch. However, the Dragon spacecraft is actually designed to withstand aerodynamic forces of both launch and re-entry, so it doesn't need a fairing today. Now, this Dragon is currently loaded with almost 6,000 pounds of cargo. Most of that cargo is loaded well in advance of launch. However, we do have a late load period, about 24 hours before launch, when the rocket is still horizontal. Now, today we're counting down to an instantaneous launch window, which means we need to launch from a precise second in order to match the orbit of the International Space Station as it rotates around the Earth. This is going to be 1 second. That we're counting down to that 1 second. You can count down along with us by following the mission progress bar at the bottom of your screen and also watching the mission countdown clock in the upper right-hand corner.
So what's inside of Dragon today? Well, along with supplies for the astronauts, we have over 40 science experiments going up. We'll highlight a couple of them here. One of the heavier payloads we're taking to orbit today is we're putting it in the Dragon trunk. It comes in at just over 700 pounds, and it's called the Roll-Out Solar Array Experiment, or ROSA. Now, solar panels are an efficient way to power satellites, but they're pretty delicate and pretty big, many times larger than the satellite itself, and oftentimes. Now, the wingspan of a typical satellite with its solar panels deployed is about 150 feet. But at launch, the satellite and solar arrays need to be 15 feet or less in diameter. This means that the solar arrays have to be folded up really tight against the satellite during launch, and then unfolded once a satellite, or a capsule like Dragon, reaches orbit. The ROSA investigation is testing a new type of solar panel that's flexible instead of rigid. So it's rolled up like a yoga mat for launch, and then rolled out like a party favor once the satellite gets to orbit. This basically means you can get a lot more power from a smaller and lighter system. Another big payload we're taking up today is the Neutron Star Interior Composition Explorer, or NICER for short. NICER weighs just over 800 pounds and, like ROSA, will go up in Dragon's trunk. It's designed to be mounted to the exterior of the space station, and it will study the physics of neutron stars. The types of neutron stars that NICER is studying are called pulsars, and they're called pulsars because of the unique way in which they emit light, and a pulsed regular radiation beam similar to that of a lighthouse beacon. Leveraging this phenomenon, NICER will demo the Station Explorer for X-ray Timing and Navigation Technology, or sextant for short. This will help researchers develop a new type of space navigation system that can provide precise positioning for spacecraft throughout the solar system, kind of like a GPS for the universe. Now there's a lot more science on this mission that we just don't have enough time to cover all of it today, but you can learn more about the other payloads going up in Dragon today on www.nasa.gov.
Great afternoon, everybody. Thank you for joining us. My name is Brian, and I'm one of the software engineers here on site at the headquarters in Hawthorne, California, where we are just 15 minutes away from excitedly launching the 11th of 20 contracted commercial resupply service missions to the International Space Station. Now, we are particularly excited about this one because it's the same one that we flew for the 4th. This is the first time we will be attempting the reflight of a Dragon. Now, because it is a Dragon mission, to give you a snapshot of what we've done to get ready for this point, we conduct a procedure called late load. Late load is where we place the time-sensitive payloads into the pressure section of Dragon. This is stuff that requires refrigeration or other sustained environments so that we place it in as late as possible to launch, so it has to sustain that launch for as short as possible. This occurred when Dragon and Falcon were in the horizontal position on the pad, and then we buttoned up the side hatch, closing off Dragon for the last time until it's opened through the forward hatch by the astronauts on board the space station. Now, after late load was completed successfully, we went vertical based on being mounted on that strong back, that transporter erector you see there on the side, into this vertical final configuration for flight position that you see it in now. Now, that happened at about T-minus 10 to 8 hours or so, and then we stepped into preparations for the next major milestone, which is the loading of propellants and pressurants onto Falcon. Now, we have two propellants on board. That's the fuel and the oxidizer. The fuel being RP1, which is basically just kerosene at a space grade, and then the oxidizer being liquid oxygen. And then the pressurant is gaseous helium. We load over 1 million pounds of those three substances combined, so it takes quite some time. Now, that started at about T-minus 45 minutes, and now here in these last minutes as we enter the final 10, we do what we call engine chills and then top-offs to make sure that we're finally ready. Now, we reached the final flight pressures for stage 1 at about T-minus 1 minute, and then second stage just thereafter. So that's a bit about Falcon. Let's shift gears here from it and learn what it takes to refurbish a Dragon.
CRS-11 is a unique mission. It's going to be the first time we are reflying a Dragon capsule. Reuse is super important to reduce the cost of access to space. Imagine if every time you've flown an airplane from Los Angeles to New York, they just threw away the airplane. Your plane ticket would be super expensive and very few people would be able to travel. So we want to change that. We want to reduce the cost of access to space, and this is especially a technology we need to enable travel to Mars and back. SpaceX and NASA have worked hard together to ensure that this flight will be just as safe as the first time we flew this vehicle in CRS-4. There are two main aspects to the reuse process. First is qualification. We have to ensure that every piece of hardware on the vehicle can withstand multiple flights. So what we do is we take a dedicated unit. So for example, a motor that would normally only be on for 30 days for a single mission in space, now for 3 flights has to be able to withstand 90 days on in space. So we have to do significantly more testing here on the ground to prove that that motor will survive 3 flights worth. The second part is ensuring that all flight hardware is recertified for its next flight. So this is looking at what do we have to do to every single piece of hardware on the vehicle to make sure it is good for the next flight. One of the key parts of the reuse process has actually been NASA. They've been a great partner through this whole process, providing us with guidance and lessons learned from shuttle. So they have been pivotal in getting us to the point we need to today to refly this capsule.
As we talk about reusing a Dragon spacecraft, it's important to remember that the Dragon actually has 2 distinct parts. The first part is this capsule. This is the conical shaped structure at the very top of the rocket. This is the part of the capsule or the part of the spacecraft that actually attaches to the International Space Station, allows astronauts to go inside and retrieve all the cargo that we're sending up. Because it's pressurized to allow for this, we typically send any cargo that needs to be pressurized inside the capsule. This includes things like food, water, medical supplies, and any types of science experiments that the astronauts are going to be doing inside the space station. The second part of the Dragon spacecraft is the trunk. That's the cylindrical section just below the capsule. In addition to holding the solar arrays for the Dragon, this is also used sort of like you'd use the flatbed of a pickup truck for large, bulky items that don't necessarily need to go inside. For instance, we usually take anything that needs to go in the exterior of the space station, things like spare parts for the structure, or any science experiments that were designed to go outside and operate in the vacuum of space. Now, this Dragon currently has 6,000 pounds of cargo. Once it finishes delivering all of those to the International Space Station, this entire spacecraft will separate from the ISS, and then the trunk and the capsule will separate, Only the capsule returns to Earth, which is why we're reusing the capsule today. Now, after the launch today, Dragon's journey to the International Space Station is really just beginning. It doesn't go straight to the ISS. It has to take a long series of 36 hours over which it performs a series of burns. It's a little counterintuitive to imagine because the International Space Station is circling. You can actually visualize it with this animation right here. If you zoom in on that circular orbit really close, you can imagine it kind of being like the ISS is flying in a straight line as the Earth rotates underneath it. Once that Falcon 9 launches from Cape Canaveral, those Dragon spacecraft will separate from the second stage once it's hit its intended parking orbit, and the Dragon will execute a series of stop-go burns called circularization and height adjust burns. You can see them here. Imagine it as sort of like a staircase going over and up, getting closer and closer to orbit match to the International Space Station. Once it gets close enough, the station's robotic arm reaches out, grabs it, and brings it in for a berthing. Like we were saying, this takes about 36 hours after the end of the launch, so we'll be keeping you up to date as Dragon gets closer and closer to the ISS. But for now, this rocket needs to get off the ground. Let's watch it as it counts down to the T-0.
Today we'll be attempting to land Stage 1 back at Landing Zone 1. Our last landing at LZ1 was our NROL-76 mission just over a month ago. Now, there are benefits to landing at Landing Zone 1 as opposed to the autonomous spaceport drone ship, which is out in the Atlantic Ocean or Pacific Ocean, depending on which site we're launching from, when the trajectory and primary mission requirements allow for us to do so. For one, it's not a moving target. It's right there on land. It stays in the same place all the time. Second, there is no prep in the beginning of the landing, or not as much prep at the landing zone as there is for the drone ship, because we don't have to send the drone ship out into the middle of the ocean in advance of the launch. There's also less time exposed to the elements because we're not bringing it back from the ocean back to the port and exposure to all that salt water and all that sea air. And also leads to faster recovery operations. By landing right at the Cape, we can more quickly step into post-flight inspections and refurbishments. Now, with today's flight being to low Earth orbit, we are flying a trajectory that requires less performance from Falcon 9 than our geostationary transfer orbit missions do. And because of this, we'll have enough fuel left over after stage set to perform that boost back burn and redirect the booster all the way back to Cape Canaveral instead of landing downrange on the drone ship. So what are we going to see as we fly back? That's the big question. Everyone loves those awesome camera views. Well, our views are very much dependent not only on our trajectory, but also, funny enough, on the human operators that literally hold the cameras and track the vehicle. So while the views could be different from landings past, we should still get some pretty cool footage. And if we get that Falcon 9 onboard footage at the conclusion of that landing burn, you know, when we're looking down on the Falcon 9 down at the ground, we might just catch a peek of the brand new paint job down at LZ1. But we are not there yet. Falcon 9 is still on the pad, and Dragon is still stacked up on top, and we're at 39A, still stepping into that terminal count. So let's check in for a status update.
Now, in order for us to be deemed ready to lift off of the surface of the Earth, we typically, in these final moments, like to check in with our 4 primary gates for liftoff, and those are the launch vehicle, the payload, the range, and the weather. Now, the launch vehicle for this mission is obviously our SpaceX Falcon 9 rocket. Our payload is Dragon to resupply the space station. Both of those in these last few minutes are undergoing very similar sequences where the onboard flight computers are conducting self-health verifications to make sure that all the systems that will be called to work in flight are working nominally on the ground just beforehand. This includes communication systems, guidance, navigation and control systems, propulsion systems, avionics boxes, and much more. Now, both vehicles also perform a final move we call going internal, which is where we, instead of relying on the external power that is snaking through that umbilical on the transporter erector, we then transition into our onboard battery systems. That means that we are fully isolated because once we take off, that umbilical detaches. So both of those vehicles are ready to go. Their supporting infrastructure is also healthy and green. Now, 39A is inside of KSC, and LZ1, our landing zone, is actually inside of Cape Canaveral Air Force Station. Both ground support equipment systems there are ready to launch and receive a healthy rocket. Now, the third item is the range. They play a vital role in our ops, including personnel safety zones, clearance of the airspace and water space around in conjunction with the FAA and Coast Guard, respectively. The range has declared go for this launch thus far. Now, the fourth item is weather. Now, Florida obviously has very mercurial weather. We had some lightning issues 48 hours ago. That appears to be much more docile today. We are tracking very slight upper altitude winds, but weather in its current state is trending better and is go for launch. So with that said, and all systems green, SpaceX is ready to fly today, so let's listen into terminal countdown.
Cradle's coming open. AFTS final setup started. Stage 1 launch says slow down. Cargo bleed verification. Strongback lowers ended. Strongback's at 88.5 degrees.
GNC announced S2 TVC motion nominal. GNC confirmed TVC motion nominal.
Stage 1 LOX has closed it out. Stage 2 LOX closed out. Vehicles in top line. Ground side gas closeouts are started.
FTS announced AFTS is ready for launch.
AFTS is ready for launch.
VC and DC verify F9 and Dragon are in startup.
F9 is in startup.
Dragon is in startup.
Gas closeouts are complete. Stage 2 is pressing for flight.
LD verify go for launch.
Go for launch.
T-minus 30. T-minus 20.
Stage 1 LOX, pressing for flight.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff of Falcon 9. Falcon 9 is clear to tower.
For stage propulsion out.
Now, as we swap camera angles, while cloud cover may make some of them not visible, the rumble is still audible as Falcon and Dragon ascend through the atmosphere. And we're about to reach supersonic speeds. You'll hear the call out on the net.
And that chill started.
Now the vehicle. Now the vehicle has gone supersonic, which means that it's traveling faster than the speed of sound, greater than Mach 1, which at that altitude is about 750 miles per hour. We have also passed max Q, which is the maximum dynamic pressure that we will experience. From here on out, it's less and less loads on the vehicle as we continue to ascend. Now we're going to come up on 4 events in rapid succession. We'll let those happen and then I'll briefly discuss what they were. But those are MECO, stage separation, second engine start, and then the boost back burn. As you just heard, we had that successful transition from the responsibilities of the first stage to the second stage. Main engine cutoff, stage separation, second stage engine start, and then the boost back burn to bring that first stage back to landing zone 1.
Stage 2 propulsion nominal.
So as you just heard from Brian, it sounds like we had a successful stage separation and a successful light of that second stage engine. That means that the Dragon is currently on its way to the International Space Station.
Now coming up soon, we're going to have a few events coming up in quick succession. We're going to have the nose cone of Dragon deploy. That's at the very top of the spacecraft, protecting it from the aerodynamic pressures and forces during ascent. Once we get into the vacuum of space, we no longer need it, and it's just extra mass, so we will jettison it. After that, the second stage burn will come to a conclusion, and shortly thereafter, Dragon will deploy.
Once Dragon is off on its own, the first thing it does is it's going to extend its solar arrays so we can start gathering that solar energy in preparation for its trip to the International Space Station. Once it has power, it'll also prime its propulsion systems. Dragon has 4 independent propulsion modules, and each of them is capable of thrusting it towards the International Space Station.
Shortly thereafter, the GNC bay door will begin its opening. That's guidance, navigation, and control. Bay door will open, and inside of that are all of Dragon's sensors that help us know where it is and help it find the International Space Station. It'll then begin to perform those height adjustment maneuvers and co-elliptic burns that Tom talked about earlier in order to get it up to the exact location at the approach ellipsoid at the International Space Station to begin that process where the Canada arm will begin to grapple the Dragon spacecraft.
And then this is all going to happen over the course of 36 hours from today. Dragon has a long way to go after it separates from that second stage. However, right now, you can see on your screen on the right is that second stage engine nozzle currently burning and thrusting Dragon to a higher orbit. On the left is the first stage. You can see those grid fins deployed. That first stage is currently guiding itself down towards landing zone 1 in Cape Canaveral, Florida.
So we have about 1 minute until our entry burn is going to begin. Now that burn is intended to slow the vehicle down as it re-enters the atmosphere. If you come in down at those super high speeds, you're going to break up the vehicle. So we got to slow it down so that it can actually guide itself more precisely to the location back down at LZ1. Once it gets closer, it'll begin that landing burn, which is the final burn in the 3-burn recovery sequence, where the center engine E9 will ignite and slow the rocket all the way down to 0 velocity.
You can currently see the cold gas thrusters in the left side of your screen. Those are helping to right the vehicle as it gets down further and further into the atmosphere, make sure it's pointed in the correct direction. And then once it gets into the atmosphere, those grid fins are going to start turning, maybe only a little bit, to help guide it through the air as it gets down towards LZ1.
Now, as we get down to LZ1, we have that onboard Falcon camera. And we have that
Stage
entry
one,
burn
entry
coming
burn
up in a few
started.
seconds. You can probably check it out here. Look on the right, you can see the first stage coming back, and that entry burn has begun. And the entry burn has shut down. And the next burn going to come up shortly thereafter is going to be that landing burn.
So we do have cameras stationed at LZ1. It's a little bit of a cloudy day still there, so we may not see the Falcon 9 first stage come all the way down. We may just catch the very end of it. That landing burn is actually pretty short. It starts only a few hundred meters off the pad. You may not be able to see it all the way down, but we hope we can get some good video.
And when we get that really cool footage, you should be able to see the fires sneak in through the frame. Again, it really depends on cloud coverage and how our tracking cameras are positioned. You could see that, that's a really cool view over to the left side, the onboard camera of Falcon 9. You can see the Earth coming closer and closer.
You can see it's passing through the cloud cover right now. The landing burn is just starting. That's a beautiful shot of that first stage of the camera. Let's watch it go down to the pad.
That is a successful touchdown of the Falcon 9 back at landing zone 1. Our 5th successful landing back at the launch site.
Now, as we all are obviously very excited to bring another one of our first stages back home, it is important to remember the primary mission is still ongoing. That is to bring the Dragon spacecraft to the International Space Station. Let's get a status update on how our primary mission is doing.
Another truly amazing landing of the first stage. We're all here very excited at the headquarters, as are those excited wasps that you just saw on your landing zone 1 screen. But let's focus back onto the primary mission now, which is how second stage is performing with Dragon. Now, second stage follows a very different burn profile than first stage. First stage has 3 burns: the boost back burn, the re-entry burn, and then the landing burn. Second stage only has 1 burn before it actually departs from Dragon. So we're about to come up on that event here in about 30 to 60 seconds or so, and we call that SECO number 1, which stands for Second Stage Engine Cutoff number 1. We'll follow through and listen into that, and then we'll discuss the events that will occur thereafter.
SECO 1.
SECO 1 as the glow of that MVAC-D engine fades. Now, the next major milestone now that second stage has stopped burning is separation from Dragon itself. It was burning for about 6.5 minutes to get us into the orbit that we need to fire our pyrotechnic devices and gently push Dragon away so that it, as a self-sustaining vehicle, can continue on to the International Space Station of its own accord. So let's listen in for separation of Dragon from second stage here in a moment. And there we have it. You are looking at a view of Dragon and second stage separating as Dragon continues solo onto its mission to traverse over the next 64 hours or so to the International Space Station. Now, it's worth reiterating what Dragon's going to be doing over the next few hours. The very first thing we do now that we are separated is we prime the propulsion system. This is when we open those pressurant valves and enable us to fire our propellants so that we can readjust and orient our position out in space. We need to do that so that we can point at the tracking and data relay satellite system first. Once we acquire those ground stations, we can confirm communication with Dragon, which opens the door for all of the events that follow. Now, after we establish TDRS, we do an event called Solar Array Deployment. As Tom mentioned earlier, the solar arrays unfurl from the side of the trunk after their fairings are released. They are doing that so that we can recharge from energy harvested from the sun so that our onboard batteries will last this multi-day journey up to the space station. That solar array deployment occurs at about T plus 10, 11, 12 minutes or so that will come up soon, and we will provide coverage of that deployment. Now, after we close out the webcast, a few events will happen thereafter, and they are worth noting, and that is the opening of the GNC bay door next at about T plus 2 hours. GNC, as Lauren mentioned, stands for Guidance, Navigation, and Control, and that bay houses all of our sensors that we need for close proximity ops with the International Space Station. LiDARs, laser detection and ranging, thermal imagers, GPS units, star trackers, etc., so that Dragon continually knows both where it is and how it's oriented. That's very important once we get close to the ISS. Now, after that GNC bay door opens at about T plus 2 hours, we then begin those slew of burns, the height adjusts and the co-elliptic burns that we need to go all the way up to the International Space Station as we inch closer and closer along that staircase to the International Space Station. Once we're there, we berth, we get captured, the astronauts offload all the cargo, we stay up there for about a month, and then we return about a month later with return cargo, splash down with attempts to refly that same Dragon again later at some point. So now we're coming up on Solar Array Deploy, that event that I mentioned a few moments ago, so let's watch that now. And there you have it. As the wings of Dragon extend slowly out from the passive springs from the trunk so that we can harvest energy from the sun over the next 2.5 days as we journey up to the space station. It has been a wonderful timeline so far for this very first reflown Dragon. Best of luck and continue on to your mission to the International Space Station.
And with that, we are coming to a close on our webcast. It's been a successful day for SpaceX, starting with Falcon 9, a successful launch of the first stage and the second stage as well, with the second stage taking Dragon to its intended orbit, and stage 1 returning to land for our 5th successful on-land recovery. And Dragon has had a wonderful start to its mission. The first reflown Dragon is now in space on its own accord. Its solar panels are deployed, and it's beginning the process of its extended mission.
So like we've been saying, Dragon's journey is going to take about 36 hours to complete to get to the ISS. Please follow along with all of our media channels to follow along with exactly how Dragon's doing. We'll be keeping you as up to date as we can. We'd like to thank NASA for being our partner in these resupply missions, now the 11th that we've flown. We'd like to thank the Air Force and the Range for supporting our launch today from Kennedy Space Center. And we'd like to thank you, the viewers, for tuning in. Thanks for watching yet another successful SpaceX launch.